Hey guys, welcome back to AlgoYogi. We are doing stack series and our last easy problem in the list is clear digits. It's a really straightforward, easy problem. So we're gonna really quickly just go through it and implement the solution. You're given a string S. Your task is to remove all digits by doing this operation repeatedly. All right. Delete the first digit and the closest known digit character to its left. So basically when you come across any digit, then anything that came before it, we need to clear the first character. All right, we're deleting all the digits anyway, and also the character that comes before it. Return the resulting string after removing all the digits. Note that the operation cannot be performed on a digit that does not have any known digit character to its left. So basically if you come across a digit and then there is nothing to the left of it, then you just move forward to its next digit. All right, so let's see how we're going to solve it. So if you see in the first example, this is my first string. That's where I need to apply the operation repeatedly. So basically I'm gonna go over checking if my current character is a digit. In this case, nothing is digits. I'm going to return my exact same string that is given to me as input. So this will be my answer. This will be my answer. Let's go to the second example. This one has digits. So when I'm actually iterating over my string, then I come across this particular digit. So what I'll do, I'll delete this digit as well as letter that's to the left of my digits. So these two will be gone. So these two are deleted. When these two are deleted, the resulting string would be C and 4. I am going to basically repeatedly do the same operation. Now again I'll start iterating over my remainder, basically whatever is left in the string now. So whenever I come across any other digits, which is 4 in this case, so again I will delete both of these, the digit and also the character to the left of the digit. These all are gone. What is left is just an empty string, and this is my answer. So I will just return this as my answer. Now we understand the problem. Let's see how we're going to actually implement the solution. And I think the best way would be to use a stack. It's a stack series, so definitely we're going to use a stack. Let me just clear things up. And the best way would be to basically to implement the solution on I would say A, B, 4, 3, like that. So what do I do is I'm going to have a stack. We have done similar problems like that before. So I'm sure if you're following the series, and I'm sure you came across these kind of problems. And whenever you see something, the problem is asking you to do some repeated action on a particular string. So whatever is left, then do the same action. Definitely think about stack being one of your solutions. And another could be 2 pointers. Even in this case, we can definitely implement a 2-pointer solution as well. But I think since we are trying to learn stack and implement its utility while solving these kind of problems, so I guess stack is one of our best solutions to definitely think of. So what I'll do is I'm gonna go over my string. Okay, yes. So I come across so I'll keep pushing my elements, my characters to my stack. So A, and then B, and whenever I see a digit, then I'll basically see what is on top of my stack and then delete that. So I will basically, when I see a digit, I'll pop whatever is on top of my stack and then move to the next character. Next character is also a digit. So I'll just basically, now my top is at 1. My top is right here. So I'll basically delete the top of my stack. All right. Let's say, what about my digit started with a number itself. So let's say I was seeing, let's say this is my input. in this case, I'm gonna get rid of this and then have my, oh my god, have my input as this. Okay, I'm just changing for the sake of clarity. So let's say if my S is 3, 4, A, B, 5. If this is my input, I will have my stack. Then I'm gonna go over 3. So if I'm seeing a digit, that means I think I need to still add it, right? Because when I will be returning, it's the remained string that I will be returning. I cannot delete this if I don't have if I don't have a character before it. So what I'll do is I will append it, then 4 I will append it, then A I will append it, B I will append it, then I see 5. So 5 means I'm seeing a digit, but remember I was still seeing the digits here, but top of my stack was also digits, so I couldn't pop that out. So I'll only pop them out if that's a character. So we can check that by alpha num or not is digit or something like that. I think alpha num alpha is the method in Python. Let's implement this. It's a big of and time complexity solution, and space will also be big of and time complexity solution. Definitely you can try the 2 pointers approach. You can have 2 pointers, one checking for a digit and another checking for if whatever the letter you have seen. All right, so delete the first digit. I'm actually gonna zoom out and also again read the description clearly. Your task is to remove all digits by doing this operation repeatedly. Delete the first digit and closest known digit character to its left. Return the resulting. Note that the operation cannot be performed on a digit that does not have any known digit characters to its left. Yeah, that makes perfect sense. Okay, I was trying to like just make sure again. Scene top right. Okay, awesome. The hotkeys stopped working. Let's have our stack. Awesome. Then we're going to iterate over our character C in S. All right, so if C dot is digit, if it is digit, I think that's the way you check it, then I will check if top of my stack, if stack and stack dot stack, let's peek on the top, dot is alpha, alphabet, basically that's the short form. Alpha is the short form of alphabet. If this is the case, then I will basically pop my stack and then continue. Else would be here, right? Else I would just append it. If this is not non-digit, then I will append it. Stack dot append C. And remember, there's one more case here. So either stack or stack's top is alpha num and you are seeing a digit. But what if this was not alpha num on the top of the stack? Then you have to append it on the top of the stack because this is a digit and you're not seeing any letter before it or any alphabet before it. So we have to append this as well. All right, we have to append this as well. Awesome. Okay, so now we can just come out of this for loop and then return our whatever is left in the stack, just combine it with empty delimiter and return that. So I'm going to zoom out. I guess this was a simple solution and I am going to run it on the examples. I am expecting it to pass all the test cases. Yes, it does. Let's submit it because it's an easy problem and this description was quite clear. So I guess it's a decent solution, but definitely try the 2-pointer approach. I'm not gonna go into it because I am doing the stack series. But definitely we could have 2 pointers, one pointing in the beginning and then another, both starting at zero index or 0 and 1, and then keep checking if when they are close to each other, if you come across any digit, the character before it, that's where you try to look for the closest alpha to delete. That's possible solution. I haven't written any 2-pointer approach solution, but I'm guessing that we should be able to use 2 pointers to solution, write the solution. Space complexity, big of n as well. All right, so that was our last easy problem from stack series. So I'll mark this solved and see you guys later. And we'll start solving basically the medium level. So there are about, I think 19 problems that are medium. I haven't added any hard, but I can definitely add later. Yeah, min stack will be the next problem, and I think it's one of the oldest problems of stack, implementing the min stack. Really popular problem. All right, so see you guys later. Bye bye.